Hi all, we welcome you at session 6 of the Python for Machine Learning Bootcamp. Hope you've enjoyed the sessions so far. This time we'll talk about data visualization tools. Last session we discussed pandas that allowed us to analyze data. However, this data was organized as tables or data frames, which are not the most convenient visualization tool. Tables cannot clearly demonstrate dependencies or patterns, while specialized visualization tools can help illustrate these effectively even to a person who is not proficient in data analysis. So, how do we better visualize our data? Let's first load the dataset. Mine is on Google Drive. That's why I first mount Google Drive and load the data frame from my CSV file that stores the Titanic dataset. You can see the first 5 rows here. You may remember from the previous session what the dataset consists of. So, how do we showcase our data? The simplest way would be to use the pandas methods that under the hood use the Pyplot module. In this case, we're calling the Hist method that created 3 histograms for us. It's 3 because we passed it a list of 3 values which correspond to some of the column names in our data frame. We've received a histogram for each column we indicated. This method has some disadvantages though. The thing is, these histograms are not very flexible. If we need to create something more complex, we need to use the Pyplot module itself. So let's look into how to use Pyplot. First of all, we need to mention that Pyplot is built into the matplotlib package, so we have to import it from matplotlib. The PLT alias is the commonly accepted combination of symbols to use while importing matplotlib. You are very likely to run into it on forums and generally on the web while researching matplotlib-related questions. Accessing the Pyplot module, I call the same histogram method that should build my histogram, and pass the X argument the title of the age column. As a result, I get a distribution of passengers by age. Right away, we can see the prevalent age group, it's 20 to 25. Please mind that we've received a simple histogram that doesn't even have axis names. We don't know what 175 is, we don't know what 80 means either. To declare these parameters, we call the corresponding Pyplot methods. For the x-axis, its x label will be named p-class, and y label will be named count. On our histogram, we can now see the labels, which makes the histogram way more readable. We're still missing an important part though, and that's the title. To set the title, we can use the title method and pass it the required text. You can see it working at the top of the histogram. Now we could also add a grid. For that, we have the grid method. It accepts a Boolean value, so true or false, but it's false by default. So when calling this method, we pass it true, which means that we do need the grid. As a result, we'll see a grid on our histogram. Let's say that we've looked at our histogram and realized that this empty space here on the left and on the right doesn't make it look any better. Obviously, age values can't be negative, and we don't have a single person older than 80. So let's establish the exact limits and not have them set by default. What I'm saying here is that the x-axis should show the values ranging from 0 to 80, and the y-axis limits should be 0 to 180. Here's what we're getting on our histogram. It's much better looking now. What other parameters can we control? Let's say we want the bars to have a specific color. The Hist method has a color argument that accepts a hexadecimal code of the color. I colored mine turquoise, but you are free to experiment and set up the one you like. So this is more or less the logic of working with simple histograms. The Pyplot principles of working with graphs are actually very similar. Let's now look at configuring a pie chart. Right now, I want to look at the distribution of how many passengers belong to each passenger class. There are 3 passenger classes. First class has the fewest passengers and it's the most expensive class, and third class has the most people and is the least expensive. A pie chart would be a good option for demonstrating this distribution. How do we work with a pie chart? First, we need to prepare data for it. From the previous session, we remember how the group by method works. I've grouped my data by the p-class column, and I have received this data frame. I'm taking the values I need from the name column. For the sheer purpose of building a graph, it's not important which column we take the data from. But when you have a specific business goal, you have to know exactly which values you need. Mind the validity of that data and make sure it's pre-processed and cleaned. Otherwise, your results will get skewed. All right, the values I want to work with are stored in the values variable. And I'm creating an explode variable. We needed to set up the sectors of the pie chart. All right, how do we set it all up? First of all, it's always a tuple. And based on the ordinal number of the sector, we pass it an offset distance. If we indicate 0, then there's no offset. And if the number is greater than 0, then the sector will be offset from the rest of the pie chart by that value. The first position in the tuple corresponds to the sector that's passed as the first row in your data frame. If we take name, then for this number, the offset will be 0. The second 0 corresponds to the second sector and the value of 184. And 0.1 corresponds to the sector that requires a slight offset, and it is the largest sector on the graph, having the greatest value of all, 491. So to create a pie chart, we need to call the pie method from Pyplot. As the argument for x, we're passing the values of the name column. The indexes of the data frame are going to be the labels. These 1, 2, and 3 will correspond to the sector labels. There's also this input parameter with which you can configure the labels on the sectors. The way I set it here is the percentage values are going to be rounded to 1 digit after the decimal point. As a result, instead of getting absolute values, I get percentages. And the third argument is the offset configuration for the sectors. I will remind you that the third sector has the offset of 0.1 from the center of the pie chart. Let's now try and build a graph that passes through specific points. The first thing that comes to mind is a parabola. It must be the simplest thing we can build after a linear function. For the x-axis, I've taken the values of -5 to 5. I've risen them to the second power and stored them in the y variable. So we've received pairs of values. -5 corresponds to 25, -4 corresponds to 16, and so on. And to build a graph passing through certain points, with each point connected to the next, I'm using the plot function. I'm passing it x as the first argument, so the list of coordinates on the x-axis, and y as the second one. This is the list of coordinates on the y-axis. I'm getting this graph as a result. This is a universal method of building linear graphs, and you can build many things using data points like that. Let's experiment some more now. There are also scatterplot graphs that you can use to picture the information in 3 dimensions. So there's an x-coordinate and a y-coordinate, and there's a value that corresponds to these coordinates. The greater the value, the larger the point will be. Let's see how we can build that. First of all, I've imported the random function. We're going to need a subset of random numbers. This means that if I rerun the code, I will get a different scatterplot every time. So you may end up getting some interesting patterns if you run the code time and time again. So here are the 3 lists that will store the values for the x and y coordinates as well as the z point values. I'm going to generate 256 points. For x and y, I'm including the values ranging from 0 to 256, and the z value will be set to range from 32 to 256. I've set the minimum number to a number that would allow us to see the points better. After I receive the 3 lists of values, I need to pass it to the scatter method of the Pyplot module. The rule of thumb is to pass x and y as the first and second arguments. As far as the z value goes, we need to pass it to the s argument. S is short for size. To indicate the color, I'm passing the C argument, which is short for color, the hexadecimal code. And I'm setting up my last argument, which is alpha. Alpha is responsible for the transparency of the points. You can obviously experiment with it and use it, or just get solid points instead. As a result, I'm getting 3 lists and a graph. There are many other visualization graphs whose features you can benefit from. There's also a resource that accumulates all kinds of possible graphs. It's replete with examples. We've included the link here in the notebook. Please mind that you can access the notebook via the link below the video. This web resource is very intuitive, but if you do run into issues, do let us know in the comments below the video so we can help. Last but not least, let's talk about homework. Your first and easiest task is to replicate a scatterplot. The slightly harder task includes trying to find a way to build a box plot and build one on your own. Again, if you run into trouble, do let us know in the comments below. We'll be happy to help. Remember to like the video if it's helping you on your way to becoming a data scientist, and subscribe to our channel for more useful content. It's a wrap for today. I thank you for your attention, and I'll see you at session 7.